Welcome back to geometry. Today we're going to talk about the trigonometric ratios, which corresponds to the Common Core standard number 8, where we use trigonometric ratios to solve right triangles. So first we're going to have a brief introduction to the trig ratios, then we're going to do one example together, and then you'll have one example to do on your own, and then I'll go over it, and then you have one extension at the end. So first we're going to use the SOHCAHTOA as an easy way to remember these trig ratios. So we know when we have a right triangle, we have three sides. So across angle theta, we have the opposite side. And then next to the angle theta, we have the adjacent side. And lastly, we have the hypotenuse, which is always the longest side of the triangle. So now, looking at this first section, we have SO, which corresponds to the sine. And sine, we have the opposite over the hypotenuse. And then we have cos, which corresponds to cosine, which is the adjacent over the hypotenuse. And lastly, we have tangent, which is the opposite over the adjacent. So if you ever get stuck, just remember SOHCAHTOA, and then you'll be able to find what the trig ratios are. So now let's use these trig ratios in a problem. So let's say we know a triangle has where the sine of theta is 4 over 5. How can we find cosine over theta? So we have this missing side right here. So now, in order to solve, remember we use the Pythagorean theorem to find any side on a right triangle. So we know a squared plus b squared is equal to c squared. So we have a squared plus 4 squared is equal to 5 squared. So then a squared plus 16 is equal to 25. Subtract 16 from both sides. A squared is equal to 9. Then we take the square root to solve for a. A is equal to 3. So going back to SOHCAHTOA, we know that cosine of theta is equal to adjacent over the hypotenuse, which is equal to 3 over 5. Moving on to the next example. Here you're going to do it yourself. So let's say we know that tangent is equal to 8 over 6. Find sine of theta and cosine of theta. Alright, now that you tried it, remember how in the last problem we used the Pythagorean theorem to find the side? So here we're going to find c. So a squared plus b squared is equal to c squared. So then we have 6 squared plus 8 squared is equal to c squared. So then 36 plus 64 is equal to c squared. So then 100 is equal to c squared. Take the square root. C is equal to 10. So then now we're asked to find sine of theta and cosine of theta. So we know from SOHCAHTOA, sine of theta is equal to the opposite over the hypotenuse, which is equal to 8 over 10. And then we have cosine of theta, which is equal to the adjacent over the hypotenuse, which is equal to 6 over 10. Alright, I hope you guys got that. If you didn't, let me know if you have any issues. So let's say we know all sides of the triangle. So that means we know sine, cosine, and tangent. But what if we want to find what theta would give us those sides? Let's think about that, and then we'll talk about that during our next class.